Hi, in this exciting chapter, we'll be learning about the world of triangles. You might think triangle is just a shape, what's so important about it? Well, actually around us, even when you don't realize, there are lots of things that resemble triangles or are actually triangles. For instance, if you think about you yourself standing away from a light pole on the street, right? The distance between you and the light pole as well as the way that the light falls on you from the pole and the pole itself. These three things make a triangle shape, and there is absolute wonder and fascination behind this, and it's used in a variety of fields from engineering and architecture all the way up to design. So let's think about triangles. Let's learn about similarity, congruency, some fascinating theorems behind triangles, and learn about the Pythagoras theorem, which you may already know, but from a different perspective. This is an exciting chapter, guys, so get pumped up and let's go. So as we begin to learn about trigonometry, we should revise what we mean by congruent and similar figures. Now, what is a figure in this context? A figure is anything that has sides and angles. It could be a square, a rectangle, a triangle, a circle, any figure at all that has a boundary with some angles. Okay, so say for example, we take a triangle. I have drawn a triangle here in blue color. And then what I did is I copy pasted the triangle. That is, I duplicated this triangle into another triangle. Now let's label this triangle as A. Let's name this triangle as B. These two triangles are exactly identical. They have the same size. They have the same shape. So what can I call these two triangles? Yes, I can call them as congruent figures or congruent triangles. The reason is they are the exact duplicates. There is no difference between these two triangles. If I put one triangle on top of another, it will perfectly match. The angles are the same and the sides are of the same exact length. So the shape is the same and the size is also the same. One is not smaller than the other. A is exactly congruent to B. This is how I mathematically show it. Now, let me take another triangle and let me call it C. Now, in this triangle, the angles are 60 degrees each and the sides are 4 centimeter each. Now, this triangle clearly is an equilateral triangle because all three sides and all three angles are equal to each other. Now, this triangle C, what I have done with it is, I have resized it. I have not changed the ratio of the sides, but I have made the entire thing smaller. So what has happened is that this chotu triangle, this little triangle that I have got, let me name it baby D. This little triangle has the same exact angles, 60, 60, 60. But the length of the sides has decreased. All three sides have become of length 2 centimeter each in this little triangle. So this little triangle D has the same angles, but it has different lengths of sides and it has a smaller size. However, if you take the ratio of the sides, let me take the ratio of the sides of triangle C. It is 4:4:4. If I simplify it, I can get 1:1:1. All three sides are equal. That is the ratio of the sides of this big triangle. Now let me take the ratio of the side lengths of the chotu triangle D. It is 2:2:2. If I simplify it, I can get 2 ones are 2, 2 ones are 2, 2 ones are 2. So again, the ratio of the side lengths in this small triangle is the same. So the small triangle is similar to the big triangle. Size may be different, but the angles are exactly same and the sides are exactly proportional. That means the ratio of the length of the sides is exactly same. 1:1:1 in both triangles. We call these as similar figures, and I can represent it like this. A is similar to B. A is similar to B. Got it? I can have similarity in circles. I can have similarity in squares. I can have similarities in any quadrilateral or any figure, as long as the angles are equal and the sides are of the same ratio. They are called similar figures. Okay? Okay, some fun examples. Let's take these questions and try to crack them. See, we have to figure out whether these two figures are similar or congruent. To remind ourselves, similar figures may have different sizes. If you resize a figure, keeping the ratio of the side lengths intact, okay, with the same exact angles, then it's a similar figure. But congruent means ditto. Congruent means there should not be any difference between the two figures. They should be of the same size and shape. Okay, you have to literally duplicate or copy paste an image to make a congruent image happen. Okay, angles also same, sides also same. That's congruent. Okay, you try to crack this before I tell you the answer. Okay, let's do it together. First question is, let's look at this figure. Let's name it A. Let's name this B. Now in A, you can see that all the angles are length 90 degrees. This kind of representation now with the square, it means the angle is 90 degrees. Now since we can see that in this figure also they're all 90 degree, in this figure also they're all 90 degree angles, we can conclude that these two figures have the same angle angle length. So equal angle is met. Now would you say they are congruent? Are they ditto the similar? No, they are not, because you can see that the side DC has length 3 centimeter, but side SR has length 3.5 centimeter. In order for these to be congruent, both of the figures should have the side lengths as equal. Okay, so in this case, the two figures are not congruent. Now we have to check, are they similar? To check if they're similar, we have to check whether the ratio of the sides is the same. In the first figure, the ratio of the sides is 3:3:3:3. If you simplify that, you will get 1:1:1:1, right? All of the sides are equal. What do you call this kind of figure? You call it a square? Yes, because the sides are equal and the angles are all 90 degree. This is a square. A is a square. Is B also a square? Does B also have same equal sides? No, it has 3.5 on two sides and only 3 on two other sides, which means that the ratio of its side lengths is not 1:1:1:1. It's something different, because one side is 3.5, another side is 3, right? So this side, when you take, even when you simplify 3:5 is to 3.5 is to 3 is to 3.5 is to 3, you will get something different than 1:1:1:1. So they don't have same ratio of sides, these two figures, so they are not similar either. They are neither similar nor congruent. Let's look at the second one, Taj Mahals. I love Taj Mahal, I've never been to it, but let's look at these figures. They are all actually resized. Someone has just taken the figure and resized it to a smaller figure. They have not changed the ratio of the sides, because the length of the sides seems to have changed in the same fashion. Say for example, this has, the first figure has lengths like 4 and 2 and 4 and 2. The second figure might have lengths like 2, 1, 2, 1, which means they have halved the lengths of each side to get the second figure. The third figure might have lengths like 1, 0.5, 1, 0.5, right? So what I'm trying to say is that they have literally resized the figures. So the side ratios have been intact. Okay, but are they congruent? Are they ditto the same with the same size? No, the sizes are clearly different, so they are not congruent. Could they be similar? What else do you need to check for similarity? Yes, their angles. Yes, their angles is what we need to check, and clearly this is all 90 degrees only. It is a perfect rectangle. So the angles are all equal. 90 degrees all angles in all three figures. So we have same ratio of sides and equal angles. They are similar figures. Last one. This one you have to guess just by looking at it. Don't these two images look like they have been copy pasted? I don't see any difference in their sizes. I don't see any difference in the radius of these circles. I don't see any difference in the distance from the center to the periphery of either of these circles. So it must be that I have copy pasted these two images. Obviously they are both circles. One is not an oval, right? So the angle must also be the same at all points of both circles. Same angle and same radius. That means same size and same shape. What does that mean? These two are congruent. Finally, we have one congruent figure. Thank God. So if they are congruent, do we need to check whether they are similar separately? No. All congruent figures are similar kids, like all congruent figures are similar, because if they're congruent, they are same, which means obviously they have the same angles and obviously they have the same ratio of sides. Okay, so congruency implies similarity. So if this is congruent, yes, it must be similar. You don't even need to check separately. Okay, but if let's take case number 2 where the Taj Mahals are similar, does it automatically mean they are congruent? No, it does not automatically mean they are congruent. Why? Because obviously they are of different sizes in this case. So similarity does not imply congruency. Does not imply congruency. Only congruency implies similarity. Isn't that cool? There's so much mathematical terminology to be learned, and you might find that it is actually very cool because you can look like a nerd, and if you want to reveal that side of yours to your friends, you can anytime pull that superpower. That's why knowing maths terms is very cool. Okay, now let's look at these two figures. In the left side, you can see something that looks like a square. The sides are all equal to each other. So it's all 2.1 centimeters. So when you do 2.1 is to 2.1 is to 2.1 is to 2.1, you get the ratio 1 is to 1 is to 1 is to 1 for all four sides of the left hand figure, which means that all of the four sides are proportional in this ratio. If you take the right hand side figure, it looks like a quadrilateral with four equal sides again. All of them are 4.2 centimeters, right? Which means again all sides are equal, and the ratio of the sides again on the right side figure is 1 is to 1 is to 1 is to 1. Now are these two similar? What do you think? They are not. Yes, they are not. Why? Why are they not? Their sides are of the same ratio. They are not similar because their angles, their corresponding angles are not equal. They are quite different. In this figure, you can clearly see that probably all of the angles are around 90 degrees in size. But in the right side figure, you can see that this is probably a little bigger than 90 degrees, each of the angles. You are not sure if the angles of these two figures are equal. Therefore, these two are not similar figures. Alright. So, similarity requires two conditions. One, that all of the angles are exactly equal, and the other, that the sides are of the same proportion. In the next video, we'll see more exciting things in this chapter and solve interesting problems.